let's talk about octahedra. The octahedron is one of my favorite solids, and I think it might be because there's so many different ways of looking at it, and so many different ways to derive it from other solids. So let's take a look at that in this video, some different ways of coming up with an octahedron. Now, the standard way might be to combine a certain number of triangles at a vertex. So let's come at the problem a little indirectly. Let's say we wanted to combine 3 triangles at a vertex. Well, at this vertex here, I would be missing one. So I would add that one, and I end up with the tetrahedron. Well, that's not what we wanted at all, of course. So let's keep trying. We could combine 5 triangles at a vertex. 1, 2, 3, 4, 5 in this way. And then I would just have to turn this over, take a look here, and see that I only have 2 at a vertex. So I would need 3 more. I could add those on here. I would proceed, see that I have 3 triangles here. I'd have to add another 2. And so I could continue. Until I get this solid here, an icosahedron, an object with 20 sides. Now what we wanted was an octahedron. So let's do this a little differently. We will combine 4 triangles at a vertex, like so. We'll turn it around, see that we only have 2 here. We need 2 more there. We'll add those on here. See at this one, 1, 2, 3, we're missing 1. We'll add another one. Here we also see we're missing 1. And we have our octahedron. So again, depending on how many triangles you combine at a vertex, you can get different solids. And if you combine 4 of them, you end up with an octahedron. That's what we wanted to find. So let's put that right over there. Let's now look at a totally different way of coming up with this shape. Let's say we had the idea to build some pyramids. Let's say we had a triangle, let's say here, and we had the idea of building a pyramid like that. And let's say that we also had the idea that we wanted to build another such pyramid, like so, and we wanted to combine these back to back. So we'll do this. There we have a new solid. We could do the same with, let's say, a pentagon as a base. Let's start with this here. We'll put some triangles here in order to form a pyramid. We could combine another 5 here to give us another such pyramid. And now we combine those, and we have a pentagonal bipyramid, right? We could use this same line of thinking to create an octahedron. Let's just start with a square. If we start with a square and create a pyramid, then we're halfway there. Let's create another one. There we have 2 such pyramids. We put them back to back, without the base, of course. And we have combined 2 pyramids. Actually, let's do this in a different color so that we can see what the derivation actually was. We'll do that in yellow. 2 pyramids, and we have an octahedron. You could also call this a rectangular bipyramid, because we started with a rectangle, specifically a square, as the base, and created two pyramids and put them back to back. So we have a square bipyramid, or an octahedron. So let's do this again. Let's say we had the idea that we wanted to build a prism. Let's say we'll start with a green triangle. We'll put some squares along the outside of this triangle and raise the walls here. And let's color code this so we have the base and the top being green and all the sides are blue. Now this is called a prism. We could also do that with, let's say, with a pentagon. So let's have a yellow pentagon as the base. We'll add some sides. Some green sides. And another yellow pentagon on top. And there we have a pentagonal prism. Now, that's a long way away from octahedron, isn't it? But we could do the following. Instead of these squares on the sides, we could have the idea to put triangles on the sides. So let's try that. Let's put blue triangles on the sides. So here we have our pentagon. We'll add one triangle, so 5 triangles in all, around this pentagon, like this. And this time when we raise the walls, there's a little gap. So we'll fill in that with a triangle as well. Here there's also a little gap. We'll fill that in with a triangle. Here's another little gap. Fill it in with a blue triangle. We'll continue in this way, filling all of these gaps in with blue triangles. And at the end, we can put our pentagon again on the top, our yellow pentagon. The interesting thing now is, if we start with the pentagon pointing downwards from this view, if we turn it around, the other pentagon is pointing upwards. This is not a prism, but an antiprism, a pentagonal antiprism. Now we could do the same thing with a triangle. Let's do that. Let's start with a red base, and we'll put some blue triangles around each side. And again, when we want to raise the walls, we'll have little gaps. We'll fill those with blue triangles. Here we have another gap. One more gap, and then we'll put the top on, which is red. And again, we're in the situation, if the base is pointing downwards, if we turn it around, then what would be the top is pointing upwards. This is an antiprism, a triangular antiprism. But it's also an octahedron, right? So an octahedron is also a triangular antiprism. So we already have 3 ways of looking at this. Let's find yet another one. Let's say we wanted to start with a larger tetrahedron. Let's do that. So let's say we had, so I don't want to build a small tetrahedron like this. I want to build a larger one with larger faces, because I'm going to be truncating that. So I want each face to look like this. We will find these pieces first, put them together. So I just need one more little face. And we're going to create a tetrahedron, and then we're going to cut off some parts of it. So let's do that this way. So this is a normal tetrahedron, just a little bit larger, and we've used 4 triangles here to use as a single face. The reason we've made it that way is because I'm going to want to truncate some of this side here. So I'm going to basically cut off the vertex here. If I were to cut off this vertex in a certain way, so exactly 1/3 of the way, I would end up with what you call a truncated tetrahedron. That's not what I want. I want an octahedron. So what I'm going to do is I'm going to truncate this vertex all the way up to this point. So basically half of this length here is going to get truncated. And I'm going to replace this tip here, this vertex, this here, with a red triangle. And then I'm also going to truncate this tip here with another red triangle. And I'll do the same with this tip here and with the back as well. So basically just every vertex I'm replacing with a red triangle. So this is what you call a rectified tetrahedron. But it's also an octahedron, as you see. So there we have our 4th way of coming up with an octahedron. Now let's do one more way, which is somewhat more involved. Let's start with a cube. And what I'm going to want to do is to create a solid that replaces each one of these vertices with a face, and each one of these faces with a vertex. So in other words, I'm going to be doing something like this. Here I have, again, a big triangle. I'm going to put that here in such a way so that this vertex here is replaced by this face, and that if I were to put 2 of these next to each other, then I end up with a vertex here where this face used to be. So let me create first the bottom half of this shape. There we have it. And now I can fit my cube into it in just the way that we described before, where you can see that this vertex here is right in the middle of this face. And now I can take some more faces. You see exactly, again, that the middle of this face is right where this vertex is here. Right here up at the top. And we'll do the same all around the other sides. And you see what we end up with. A shape who has faces exactly where the vertices used to be, and it has a vertex exactly where the faces used to be. And what do we have? Lo and behold, we have another octahedron. So you see, we can create octahedra by combining 4 triangles and a vertex, or through putting 2 pyramids back to back, through a triangular antiprism, through a rectified tetrahedron, or through replacing the vertices of a cube with faces and the faces of a cube with vertices, creating what is called the dual solid of a cube, which is also known as the octahedron.